Water's not gonna move back and forth from here forward unless there's ADH. So let's talk about ADH. So what does ADH actually do? That was very antidiuretic, which means
it reduces production. Well, it puts solids back into the body.
ADH actually doesn't work with solutes. But, I mean, so being an antidiuretic, so what is an antiuretic? What does that mean?
Reduces urine production.
Yeah. So, normally, in this collecting duct, you know, I have all my solutes and everything that I've collected over the course of this. And so, let's say my concentration is 100. Right, so my urine is concentrated at 100 milliosmoles per kilogram. And so that would be, you know, let's say that's fairly dilute urine. It'd probably come out pretty clear, right? What ADH does, ADH, is it water soluble or lipid soluble? Water soluble. So how do water soluble hormones work?
They have G protein.
Good. So, if you had to guess, how would ADH work? I mean, we're trying to get more water.
It activates G proteins.
That
Activate aquaporins.
aquaporins, good. Okay, so normally this is, so, you know, up to this point we've kind of lied to you and said that water moves by simple diffusion. It's really not true. Water does have a charge, and so water can't get, all of our cells, water technically does not move by simple diffusion, even though we've told you it has. It was just easier that way. But truthfully, you have to have aquaporins in order for water to move across the membrane. That's aquaporin. So that's why the water is impermeable here, because there are no aquaporins normally. But ADH opens up a G protein, or activates a G protein, that activates aquaporins. So this is figure 2618. So, mainly in the collecting duct, some in the distal tubule, we open up aquaporins. And water, if we make it available for that water to leave, what's it going to want to do?
Leave.
It wants to leave. And why does it want to? That is a dumb question. Why does the water want to leave?
Because it wants to follow the solutes.
Right, because as we get deeper into the nephron, towards the medulla, right, the collecting duct is still going deeper. We want to level out. So water is going to be leaving all the way through here into the interstitial fluid, which then, like we said earlier, makes its way to the blood, right? Marker's terrible. So now, instead of our urine being the same concentration all the way down, it gets more and more concentrated as we go.
And ADH causes this?
ADH is what opens up these aquaporins, yeah? What activates these aquaporins. So now, instead of my urine having a concentration of 100, it's got a concentration of 1200. It's a lot darker, a lot more concentrated, a lot more salty and acidic and everything else, because we pulled all that water out of it and instead put that water into the blood.
So the effect of ADH is really putting water in the blood.
Yep. So when does ADH get triggered? Under what conditions?
Low blood pressure.
Low blood pressure, which is true. although ADH is typically, we didn't really talk about this before we talked about ADH, but it's typically more because of osmotic pressure, more because of concentration. So if our blood becomes a little extra concentrated because we're dehydrated, that's mainly when ADH is going to kick in. It does kick in with low blood pressure too, but I guess when you think ADH, think more dehydration, high concentration of blood in the blood. So we're going to try to dilute the blood.